Will now be recorded.
Everyone, very good morning. Myself, Rasek Reddy Bolla. I'm having 14 plus years of experience into the SQL DBA development, performance tuning, Postgres DBA. Yeah. So, team, today let's talk about on the indexed view. Okay. So we can create a view on table, right? Huh? View is it won't physically stores the data, but a indexed view, we are storing the data in a view. Huh? So which scenario this will be used and all, let's discuss. This is a very important topic team. Huh? Maybe on this topic team, I don't think so. We have a lot of content available on YouTube or in social media, but this is really very important indexed view. This will improve this this is drastically improve the performance of the base table tape. Really, very drastically improve. Huh? So normally, like this one, where you can use is indexed view on very large table. Okay, millions of rows on the table. You can use this indexed view. Huh? So see, basically, if it is a smaller data on a table, what we will do, smaller table data, like to speed up the queries, select queries or update, delete queries. How are you going to improve? Huh? So by adding some indexes, okay, so that this will improve the select queries. If you update, delete queries, like if you use where class columns or join class columns, order by columns, if you have a index, that will improve. Huh? Basically, per table, like we create 5 or 6 indexes, not more than that in OLTP environment. Okay, so basically we should have the clustered index team. Clustered index is very important. So before like you can watch my videos team how important the clustered index is. Okay, where you don't have a index, there that clustered index helps. Okay, so yeah, so team, this indexed view, hmm, see, this is a table team. Okay, so I want to retrieve, like people wanted to retrieve the data. This is a base table. Sales order header. Okay, so see, I'm getting the data here, like it's a AdventureWorks database, like it's a small database team. So if it is a very big size database, this will take a lot of time. Retrieving the data, it will take a lot of time. If you see the execution plan also, either estimated or actual execution plan, can you see here hash match when you see, like when large data computed. Okay, so hash match, you can see. Huh? So merge joins, hash match joins. Okay, these are all in execution plans. You might aware on large tables. So hash match, it will sort it in general. So see here. Okay, to improve this query performance, what we will do in general. Okay, so being a DBA guy, like maybe we created a index on customer ID and order ID. We can go and create a index on customer ID and order ID. That will improve the performance of the table. Yes. And also, if you want to add included columns, you can also add these two. I mean, not required because it's already covered here. Okay, just create an index on these two. See here what people are doing, like people are retrieving the data for unique customer ID and order ID. Okay, so not no duplicates. Each customer uh, different order dates, not duplicates. So each customer different dates they want, unique rows. Huh? So for that purpose, group by people used. So this is taking time. Assume, okay, this taking time, lot of time, and it hits the CPU. Okay, a large it consumes a lot of CPU team because group by, see, computation. Huh? So aggregation. This kind of aggregations and all, it uses a lot of CPU team. Okay, when you are working on terabyte databases, this kind of queries, it hits the performance really very badly. Okay, so to improve the performance, like usually suggest create a index on these two. Man, see, this is a very big table. Okay, if you add a index on again these two columns, you already have sufficient indexes on this table. Huh? Will it like inserts become slows down if you add additional indexes? Yes, that's true. Like it's already a very big table. Having more indexes, obviously, that scale down the performance. Inspect irrespective of, like, sorry, in the terms of inserting the data, because if you insert, update, delete the data, index also need to be modified every time. Okay, so like managers, even DBS also not to add the indexes. Okay, not to add the, not recommended, sir. Because insert query is also very important for this table. Okay, so this is most transactional table, Ajub. Uh, so in such case, what kind of options you have to improve the table performances? So being a like DBA guys, first they suggest the index. Okay, not recommended to create the index. Then what other options we have to improve the table performance? Okay, so we have team in RDBMS, like we try to propose the solutions of purging, archiving, and data partitioning. Okay, on large tables team, we handle large data we can handle this way. Purging means deleting old data. Okay, so really if you don't need the old data, delete chunk by chunk, so that table become the smaller, and you can, I mean, the data retrieval faster, obviously. Like all the queries become faster, obviously, on smaller tables. But this is also not possible. Customer says they want the all the data. Maybe if you can look for archival. Okay, archival means the old data dump into some other table. See here, like so this way also existing table becomes super fast, because the all the old data you are copying to some other table. Uh, this is also not suggested. You know, customer want or client want to, they want all the data in the same. The next option we have is a partitioning. Okay, data partitioning. So you can divide the data into like smaller virtual tables. Partitioning also it improves a lot. Okay, so on million rows of table, partitioning is really helps. But partitioning also you have already, but somehow that's already a big table. But creating a partitioning on that table, it again performance hit. Okay, but on the partition table team, if you use partition column on where class or join columns only, you can see the performance. If you don't use that partition column, again, no use. See, these are all such scenarios. Still, you want to improve the query of the table. The last option we have is materialized view. Okay, materialized view or indexed view. Okay, so here materialized meaning physical. Okay, the plan is materialized. It's an English word. The plan is materialized. Plan is materialized means plan is ready, physically ready. That's the meaning. Okay, so see, view is a logical thing. It won't store the data. Okay, when you run see here, it's a table, right? This is the table. So if sp underscore space used, uh, if you run this, it will show some data. Okay, uh, it's a schema name, sales dot. See, we have some data. Okay, so if you create a view on this thing, okay, general, a normal view. uh, so create a view. CRA, create view, view name, some ABC. Okay, VW, sales order. Okay, so it's a view. Create view, view name as. Huh? See, we have a view. Like if you run select star from view also, you get the data. Okay, so when you run this select star from view means internally, okay, this query only running in the background. See, when I selected the execution planting, okay, see in the background it is running on the sales order table, but still see no use thing. Okay, if you run this query or this query, okay, no use, no performance improvement here. See, it's the same execution plan, hash match only. See, this view, does this occupy any space? No. Okay. See, does this occupy any space? See, no, no rows. Okay. So this is not materialized. This is not materialized. Means not physically stores any data. It's just like schema, the big query, like compacted format, it is showing. Okay, it's hiding all the big query into a smaller. uh, so it's just a normal view team. It's not a materialized view. A materialized means it stores the data. Where it stores the data? If you create a index on the view, if you create a index on the view, that we call it as a materialized view. Can we directly create a index on the direct, sorry, can you create a index on directly view? No, sir. Okay, we have to create a first schema binding view. Okay, schema binding view means no. So okay, you just need to add schema binding thing. I will show you. See, just okay with the schema binding. That means team. Okay, with the schema binding, if you add, that means team, you are locking the schema of this table. Okay, so schema binding view means it's not a materialized view again. Okay, see here, I'm just creating a view. So see, when you run this query, see this a okay material. It's not a materialized view. This just a schema binding view. That means uh, this table won't allow the changes of the column. Okay, if you want to change any columns, if you want to change the columns theme, first we have to drop this schema binding view. Okay, and changes the column. See, schema binding view means okay, schema binding view. There should be definition here. Yeah, a schema bounded view is a view in SQL Server that is locked to the schema of its underlying tables. Okay, so on this schema bounded view, you can create a index that will become the materialized view. Okay, simple definition. Huh? So materialized view means under a view, just normal, not normal view team, you have to lock the table, schema bounded, lock the schema, not the entire data team, just lock the schema. That means you cannot change the columns of that table directly because that is bounded, dependent. Okay, so if you create a schema bounded view along with indexed, say, I don't create a, I will show you. See team, even if you create a schema bounded view or just normal view, this won't help you to improve your table performance. Getting me? See, this is really very fantastic feature team. Okay, most people are maybe not aware of team this option. Okay, so even when I how many people use this and like I don't find much information on this on social media. That's why I wanted to make a video on this in depth. Huh? Yeah. So team, this really improves the performance of the table team, the main table on large tables without touching that large table team. Okay, you can improve the performance. This is really a magic. Okay, see here. Uh, see, this is the table, right? So let me create a uh, schema binding view on this table. Okay, sales order table. So team, say the same script I am giving here, but the extra thing is count big star. I am keeping an extra. Okay, so see team, an indexed view, you have to keep this one team. Okay, if you don't keep it team, you cannot create the index on this one. So you cannot create the index on this one team. Let me show you. Yeah. So see here, if I don't use a count star team, I can create a schema bounded view. Hmm? But it will not become the materialized view. Okay. See, this won't physically stores any data. Huh? So just this is a normal view only. But you are locking the schema. With schema binding means you are locking the schema. That means you cannot change the column names. That and all in the sales order directly. So just this can be used for to lock the schema. Just an important thing, team. There are some important tables. Don't want to allow to change. Such kind of scenarios. People will use this schema binding views. Okay. See, this schema binding view when it become the materialized view, when you add the index. Okay. See, I am creating an index. See, I cannot add. Why you cannot add the index name? Huh? Because see, cannot find the. Okay. Why you cannot find this one, right? Yeah. So did I created this one already? Okay, it's already there. Yeah. See, cannot create an index because its select list doesn't include the proper use of count big. Huh? So let me tell you, team. Okay, this is very important. I mean, tough to understand also this count concept. Huh? So see here, what you are doing here. You are getting the unique rows. Yes or no? Group by means unique rows. Huh? If we give like a count star in general, if we give count star in general, like this customer ID, order ID, how many duplicates are there? It gives that. Okay, count star, it gives the duplicates, number of duplicates of each customer ID with order date. It will give the duplicates. Okay, see, team, if you don't have count star team, so how this materialized view it works is, okay, so tomorrow if you insert any data, if you insert update delete any data on this table team, okay, so this view also storing the data, right, in the form of index. It is storing the data. So this index also will be modified automatically when you insert update delete any data on this main table. Okay, if you insert team, if you insert, this also will be modified automatically where you insert on the main table. Okay, so team, suppose if it is inserted the duplicate data like customer ID, order ID, same customer order ID, if it is inserted, then how it stores the data, how it will come to know, team. Okay, so if you use count star team, okay, so see here, when you add a duplicate data also, count will increase. Earlier two duplicates are there. Now if you insert same order data and customer, now three duplicates, four duplicates, like that. See, every time it triggers, even though duplicate data also will be inserted. If you have a count star, if you don't have count star, then there is no change, right? When there is no change on this index, obviously. That's why, team, when you are creating a indexed view, so the mandatory thing is count big star is the mandatory. Okay, so only with schema binding it's fine, it won't expect, but a view you are making it as a materialized view, then it expects count star with some column name. Okay, yeah, see now, like we already have a view this one, right? Just drop this one first. Huh? So drop view name. Now create a view again. I created. Now add the index. Huh? See, see if you don't add the index thing. See if you don't add the index thing. Like let me run a query. Which query? Select query. Normal query. Let's run it. Huh? I created a view team. See when I run select star from table. Okay, with the execution plan. Let's add the execution plan. See here, no improvement. You add a view. You have added a view, but I haven't created this index yet. Okay, not created this one team. See, will it improve the performance of this table? No. But if you use directly this view, will it improve the performance? No. Okay, no. See, same execution plan. But team, see, notice here, when you create a unique index, unique clustered or non-clustered, okay, see, I created. Can you see the performance now, team? Okay, see, when you run this query, team, see, before hash match, right? Oh my God, how many rows? 3, 1, 4, 6, 5 rows. It has read in the, read and hash match happened in the background. Okay, so let me take this screenshot. Okay, let's take a sniping tool. Let's take this one. See, the drastically you can see the performance thing here. See, when I run the same query, and the same table, can you see now the magic of materialized index? You can see now. See, like super fast this is. Okay, immediately you get the data take. See execution plan. Wow, there is no hash match. Okay, there is no hash match. See team, see the comparison before the execution plan and this execution plan. Okay, this is a I can say more than 90% faster than the previous query. See team, I didn't change any query on the application side or procedure side. I didn't change any query team. Okay, no modifications are required. Just I created a materialized view automatically in the background. It taken the materialized view. See team? So what you are doing here, customer ID and ordered ID with group by this computed data. See, this is already like when you run this, what happens? It will group by and it will compute like the operation will be performed after running this. But when you run this team now, before it will perform all this and it will display the data. But now team, it won't perform all this because already performed data we have in the view. Okay, already performed data we have already in the view. Just that data it picks and it shows immediately. That happens team. That's the benefit of materialized view. See, it automatically replaces this one by with the view automatically. See here, view sales summary it is using. Though I ran the query on the main table, okay, main table that is replaced by with the view. Okay, so here team, how it automatically replaces. Okay, it's like for you maybe like it little strange, right? Yeah, so team, here in SQL servers enterprise edition and developer editions automatically replaces them. But when you use this feature like um, other edition, standard edition and express edition, not automatically like replaces. Okay, so when you want to replaces, then you have to use this table only team. Okay, you have to use this table only. It shows the data like this. So you have to replace that one with the this one. See the same 31406 rows. Here also 31406 rows. Okay, see the same. Okay, so you need to replace this one. I mean the main table is replaced by the view. Where? In other editions. but enterprise and developer editions, it automatically replaces by with the view. Okay, so team, like can we see the difference group by and this one? People who don't have T-SQL knowledge team, it's time to learn a team T-SQL. Okay, because nowadays we all know, right? So DBA role is uh, changing day by day. Okay, we have, being a DBA, you have to work on all database management systems. Yes or no? Because like AI, cloud, so we are like a SQL DBA guy, Oracle DBA guy. Now those are all the rules before. Now like a DBA, you cannot like a DBA. Our role is a DBA. We need to work on all database management systems now. Okay, so that's kind of a the role it's shaped now, team. Yeah. So see, team, if I run this query 31465, why 31465 rows? When I run this one, 31465 rows. But when I run this with group by, it is showing 31406. Okay, 31406, because this having the duplicate data t, like same customer order data, we have a duplicate. See, if I run this query, how many rows? 31406. That means this not having not a duplicate data, because this is containing of what? This data. Okay, this is already having the computed data. Group by already happened on this view. That's why it's showing only like unique rows. If it is like non-enterprise, non-developer editions, we have to replace the main table with this one. And with enterprise, you don't need to team. Directly, you can run the query that automatically replaces by with this view. Okay, so how are you gonna like this is a materialized view? How are you gonna say materialized view? Because this stores some data. I mean, this is storing the data. So team, when you insert, update, delete the data on this table, every time, okay, this view will be called. I mean, this view will be called, and the data, the modifications of the data will be updated itself. Updated team. So sp underscore space used. This is the beautiful command team. Okay, you can use it for size of the table and size of the count of the and index sizes and all you can see here. Can you see here? See this view containing the data now. This is because materialized view this is. Okay. So we have an index. So but on the main table, do we have this index? On the main table, do we have this index? No. Okay. See, I'm just selecting main table, Alt F1. Alt F1 means properties of the table. See, on the main table, do you see this index team? No. So why this is taking time is because I enabled this actual execution time. That's why it's taking time. Just disable and run it. Okay. Sales order detail. See, we don't have that index here. IXVW. See, IXVW nowhere. Okay. So IXVW nowhere. See, you are creating a index on the view team. So this will improve the drastical performance of your query. So see, drastical improvement. So see, let me run both the queries at a time, but I cannot run both the queries at a time, right? Because it is automatically replacing, because I have an enterprise edition. This is automatically replacing, but I don't want to replace by with the view for this physical table. Then we have some option thing. Okay, what is that option is with the expand option. Okay, so with the option, okay, with option expand view. Okay, expand view. That means it will run the main table only thing. Can you see? I executed this. But internally, can you see? The main table only called. You got it? See, if you compare the performance of both the two, so team, expand views. Expand view is nothing but team. Okay. What is inside the code? What is inside in the view? That query, please run. Okay. That is the meaning here. Okay. Expand view means like what is inside the view. So I'm not using count and all team, just only these two. What are all the inside in the view, that query run. That's the meaning team. Okay. Expand, expand, expand the view. No expand. No expand also we have team. That's syntax. No expand means force the view to use instead of main table. That's the meaning. Okay. But by default, it is no expand on enterprise and developer editions. See here, you can clearly see the difference of these two. Just remove the go and just together. Let's see the execution plan. Only execution plan. See the above query running on the view, materialized view. This uses the index on the view, not on the main table. Okay. See the other query directly on the main table. Say this query like materialized view, it improves the existing query by the 90%. 90% improvement you can see. Suppose previous query taking 9 minutes. After creating indexed view, that runs only 1 minute. See 9 minutes, 8 minutes of time you saved. Okay, drastically improves the performance. So this kind of materialized view where you can create. So the table which you are not changing the column names mostly team on such kind of like mostly you can go with creating on this one team, because this is schema binding. Schema binding means when you want to change the column name, that and all team like you need to drop this view. Okay, again you have to recreate it. Yeah. So this is about the indexed view team. Yeah. So yeah. So
Conference
Tim,
will
one
now
more
be
important
recorded.
thing, like I showed you here, right? The execution plan, the difference. Let me show you logical reads, physical reads, and the CPU elapsed time and all. That way also, like you can see the performance. Set to statistics, IO time on. I just ran, right? Let's see the difference between these two. One is using directly. Okay. Uh, let's include the actual execution plan and along with. Yeah. So without execution plan also you can run it. Just I want to see the statistics of these two. Can you see here the last one? The last one is expand views means like it is using the main table directly. Okay, main table only it is using. See if you use the main table, elapsed time 2 to 6. Okay, 2 to 6. Say 8 milliseconds only. Okay, so see 8 milliseconds only. Uh, the one before SQL Server execution times. Yeah, SQL Server execution times 216. This is SQL Server 226. See 216. See less execution time taken. Okay, 31 milliseconds. This is so here 32 milliseconds and more elapsed time. This is the one thing. And if you want to see logical reads, compile time. These are all compile times. Parse and compile times. So here also parse and compile times you can see. You can compare. And majorly logical reads and physical reads you can see. So it drastically improves the read city. Okay, because this is a very smaller table team. Uh, this is a smaller table, but in real time team, you can see the drastical improvement. See here, 115 logical reads, here 119 logical reads. Physical reads 0 because all the data already stored in the memory. That's why it's showing logical reads. If it is very big team, like uh, on the main table, maybe you can see the physical reads. Okay, so this way also you can check the performance of the like materialized view versus and main table versus main table. Okay, and did I forget anything to add this materialized view? Mm, yeah. So team, see, don't to forget about this one team. Like count big star. This is mandatory team. This is mandatory for materialized view. Huh? Why? Because team, I just explained. So it has to trigger this view. It has to trigger every time when you add, update, delete the data. When you add, update, delete, insert the data, every time it has to update the data and keep ready the data. See, the data it is keeps ready with this. It won't calculate and display. It's already calculated the data and display directly. That's the materialized view benefit. Okay, so you have to this one team. Otherwise, if you don't keep this one team, SQL engine don't know which row modified, which row updated when you have it duplicates. Huh? So that's why team. So this is mandatory for the materialized view. Huh? So yeah, and don't give star and all team. Star and all. So materialized views. Huh? So indexed views. That doesn't work star. When you add creating schema binding views, you have to keep dbo dot or some whatever you have a schema user defined your own schema, you can also keep that schema name, or dbo you have to keep mandatory two names. huh? Yeah, so there are some usage of that arts there in the this documentation. You can go through it. I will also attach this document. Okay, you can just download this document also. If you like this video team, don't forget to subscribe my YouTube channel and also keep liking my videos. And if you need more videos on the future, okay, you can also comment it. So again, team, myself Rasikar Reddy Bulla. I'm having 14 plus years of experience into SQL Server DBA, Postgres DBA. If you need any help and support on the SQL DBA side or Postgres DBA side or performance tuning side or any query improvement, if you need any help, just don't hesitate to reach me. Okay, so my number is 9966246368. Thank you team, thanks for watching this video. Stay connected always. Have a nice day.